Hello. Hello, I'm audible. Hello.
Huh.
Okay. So, good evening, everyone. I am Apurva Ghosh, the owner of Mission Physics. So, what I told you guys, this is the first and only demo class of Arduino 2024 session. Okay. So, attend this live session. If you have any query, feel free to ask Ankush because he is an expert on it. Okay. So, after attending this live session, demo session, okay, not only this is not a demo session, this is lecture one, you can say. So after attending this lecture one, if you wanted to buy our premium plan, so feel free to inbox me. Here some of you have previously MP registered candidate already know the processes, okay. So don't worry, to continue the rest courses, rest classes, and so you have to register yourself in Mission Physics by buying our premium plan, okay. So to buy your premium plan, simply inbox me. I will let you know all the premium buying and registration processes. Okay. So some of you here, Calcutta University student, right? Response, please response.
Huh.
ওকে ওকে সো ফর ইউ আই এম টেলিং ইউ ইন বেঙ্গলি। তো যারা যারা ক্যালকাটা ইউনিভার্সিটি থেকে আছিস তাদের আশা করি অনেকেরই এসএসসি পেপারে অর্ডিনো থাকে, ওকে। তো তোদের ওই অর্ডিনোটা মেনলি হচ্ছে নট অনলি ফর ক্যালকাটা ইউনিভার্সিটি, অর্ডিনো কোর্স ইজ ফর অল স্টুডেন্টস বিকজ ইন প্রিভিয়াস ল্যাটেক কোর্স we have some students from Kerala, okay. So this is why অর্ডিনো কোর্স, সরি বেঙ্গলিতে বলছি। সো অর্ডিনো কোর্সের ল্যাঙ্গুয়েজটা ইংলিশ হবে, ঠিক আছে। আমি তোদের ক্যালকাটা ইউনিভার্সিটির জন্য বেঙ্গলিতে বলছি। অর্ডিনো কোর্সের ল্যাঙ্গুয়েজটা ইংলিশে হবে, আর তোদের যে ক্যালকাটা ইউনিভার্সিটি সেমিস্টার 4 CUPLP4 যে কোর্সটা আছে সেটা বেঙ্গলিতে বলবে, ঠিক আছে, যেহেতু ওটা শুধুমাত্র ক্যালকাটা ইউনিভার্সিটির জন্য। আগের আমাদের ল্যাটিকে কোর্সে সমস্যা হয়েছিল ল্যাঙ্গুয়েজের, অনেকে কেরালা থেকে কয়েকজন স্টুডেন্ট পরবর্তীকালে জয়েন হয়েছিল, তারা বাংলা বোঝে না, তো তাদের জন্য আমাদের পরবর্তীকালে আবার ইংলিশে করতে হয়েছিল। তো সেই জন্য এই যে অর্ডিনো কোর্সটা ল্যাঙ্গুয়েজটা পুরোপুরি ইংলিশে হবে, আর সেমিস্টার 4 পাইথনের কোর্সটা পুরোপুরি বেঙ্গলিতে পড়ানো, ওকে। তো অর্ডিনোটা সবার জন্য, নট অনলি ফর ক্যালকাটা ইউনিভার্সিটি, আমি বললাম। তোদের যারা যারা ক্যালকাটা ইউনিভার্সিটি আছে, যাদের যাদের আর কি মানে অর্ডিনোটা এসএসসি পেপারে আছে, এবং তাদের ক্ষেত্রে আমার যেটা মনে হয় তোদের যে কোর্সটা অর্ডিনো আর সিইউপিএলপি করে কম্বো যে কোর্স আছে সেটা তোদের পক্ষে কিনে নেওয়া সুবিধাজনক হবে। কালকে তোদের সিইউ সেমিস্টার 4 পাইথনের ফার্স্ট ক্লাসও সৌজিৎ নেবে, পরবর্তীকালে আর একটা ফ্রি ক্লাস, দুটো ক্লাস ফ্রি হবে, তার পরবর্তীকালে মানে তোদের কোর্সটা পুরো কোর্সটা কন্টিনিউ করার জন্য আমাদের মানে সার্ভিসে রেজিস্ট্রেশন করতে হবে প্রিমিয়াম প্ল্যান বাই করে, ওকে। সো আজ থেকে রেজিস্ট্রেশন স্টার্ট করে দিলাম আমি। সো রেজিস্ট্রেশনের জন্য সিম্পলি আমাকে ইনবক্স করে আমি প্রসেস বলে দেবো, ওকে। সো ফর অর্ডিনো কোর্স 500, এটা 500 is the exact price, and now 20% off is ongoing, and this off will end on 10th of April, okay. So try to register before 10th April 11:59 p.m. and we have limited seats, okay, we have an unlimited seats, so try to register as up. So that's it. If you buy only Arduino, then 10th April तक वो जो 500 के बाद 20% ऑफ लगा के जो 400 हो रहा है, 400 तुम लोगों का प्राइस पड़ेगा। और अगर सिर्फ CUPLP4 কোর্স অর্থাৎ যেটাকে বলে আমরা ক্যালকাটা ইউনিভার্সিটির জন্য যদি বাংলা আমি বলি যে সেমিস্টার 4 পাইথন, তো সেই কোর্সটা তোদের হচ্ছে 1350 টাকা অফারে, ওটাও তোদের 10th এপ্রিল পর্যন্ত অফারটা ভ্যালিড থাকবে, ঠিক আছে। আজ থেকে রেজিস্ট্রেশন স্টার্ট হয়ে যাচ্ছে, তো তোরা রেজিস্ট্রেশন করতে হলে আমাকে ইনবক্স করিস, আমি প্রসেস বলে দেবো। আর কম্বোটা তো 1350 প্লাস 400 1750 হচ্ছে, তো এখন 100% একটা অফ পাবি, সরি 100 টাকা অফ পাবি। তো 1650 এই অফারটাও তোদের 10th এপ্রিল পর্যন্ত ভ্যালিড থাকবে, ঠিক আছে। তো এই যে ফ্রি ক্লাসগুলো, ফ্রি ক্লাসের রেকর্ডেড আমাদের ইউটিউব চ্যানেলে আপলোড হবে, ডোন্ট ওয়ারি। তো ফ্রি ক্লাসের রেকর্ডগুলো পেয়ে যাবে, কিন্তু বাকি রেস্ট ক্লাসের রেকর্ডগুলো তোরা পাবি না, সেক্ষেত্রে তোদের রেজিস্ট্রেশন করতে হবে মিশন ফিজিক্স, ওকে। সো দ্যাটস ইট। ইফ ইউ হ্যাভ এনি কোয়ারি ফিল ফ্রি টু আস্ক মি। কিছু জিজ্ঞাসা আছে? ওকে, সো অঙ্কুশ, you may start now.
Okay, then let's start the session. First of all, am I audible? Somebody response, please.
হ্যাঁ শোনা যাচ্ছে।
Okay, so let me start the presentation. I hope you can see the presentation screen. Please response.
হ্যাঁ স্যার
Okay, so this will be just a introductory class. Nothing very much deep content will be there, just introduction to Arduino. This will be a brief session about that. So you can see the contents. We will just cover the basics of these topics and we will go deep in the next sessions. Let's jump into the overview part. So what is Arduino? Basically, Arduino is an open source platform for electronics. Now you may ask, what is open source platform? A open source platform is like someone build an app or software and then they made the source code available to the public domain. This is totally different from like Microsoft Word, Microsoft PowerPoint. They don't share their source code, so nobody can change that. There is a license, but since it is open source, from public we can also access the source code and we can edit that code for our customization. So Arduino is a very customizable platform for electronics where we can set up different sensors, actuators, output devices and use some basic programming language, mostly a simpler version of C++. So I will be going to that also in a later part. Now using that coding part we can get some input from the sensors, we can process the data as per our requirement and give some output, or we may just show it on a screen, okay, or you may transmit. There are lots of possibility. Even I don't know such possibilities. You may you may try that also. There are transmission, so you can make two Arduino boards, in fact transmit within them. So there are lots of possibilities. So the next point will be, yeah, Arduino boards are essentially
তোমার ওই ড্রোনের সার্কিটটা একবার দেখিয়ে দিও সবাইকে।
that will be very much advanced part. It will be covered in the later session. So Arduino boards are essentially mini computers. So actually Arduino boards have a microcontroller on board. Now what is a microcontroller, you may ask? So I will just briefly address that. Microcontroller is like a integrated circuit which has a microprocessor on board, like our PC has some processors, same but less powerful. There's a microcontroller in which there is a microprocessor and some memory, some input output channels. I mean, it's just like a small set of computer which can be used in embedded system purposes. Like we have a microcontroller like Atmega 328P on Arduino Uno. Other uses of microcontroller would be, let us consider the washing machine. There is a microcontroller inside that which controls the, which takes inputs from the buttons and process according to that. These are called embedded systems which can perform some specific task based on some inputs and give the outputs. So let's move on to the next point. I already told this point. Because it is open source, there is a large community of Arduino users who share their ideas, tutorials and projects. This makes it a great platform for beginners to learn about the fusion of electronics and programming, and for advanced users it is a heaven for developing creative projects. So you can create so many projects, there is no limit actually. So moving to the history, see, this history part is just for information. In the university question paper they may ask, but this is of no use in this course actually. So I will just mention few points. You can go deep if you are fond of history or something like that. So there was first wiring. After that Arduino was developed. All this was developed in this institute, Interaction Design Institute in Milan, Italy. So there are some scientists, actually Massimo and David, they created the Arduino. Before there was wiring. The wiring project was developed by this person. You can Google them also. So the modification on the wiring created the Arduino, which was a milestone actually. So after that the software of Arduino was developed. This was basically a JavaScript software which can be programmed using the C++ language. Actually little different from C++, but mostly it follows the C++ instructions. So this is how the journey of Arduino started. As soon as it reached a wider community, the Arduino board and shield started changing to adapt. I mean, since it is open source, there was a huge community. So everyone customized it for their purposes. Many shields was built. Now you may ask, what are shields? So look, Arduino, the actual board has limited potential. Like they have some limited number of input channels, limited number of output channels. But if you want to connect to multiple output channels, so you may add some prototype shield on that. Then there will be an expansion of ports. This is the main purpose of shields. So different kinds of shields were invented. 8-bit boards, product to IoT applications, wearable. Arduino and this type of systems are used everywhere in this day to day. So as all boards and software are open source, this empowers users to build them independently and eventually adapt them to their particular need, just as I said. So now there are different types of Arduino boards. I mean, so much variations. But the most popular one are mainly these Uno, this Nano and this Mega. These are very popular. Others are also popular. Leonardo was very popular some decades back. These were not much popular, but this was popular, and there are many, so I can't cover all of them. But in this course we will be using the Arduino Uno as our content because it is the most popular and used everywhere. So this is the why. Now why Arduino? So Arduino boards are able to read analog digital input signals from different sensors and turn it into an output, such as activating a motor, turning some LEDs on off, connecting to a cloud, and many other actions. So there is different kinds of action. You may imagine other than these also, Arduino can do everything, almost. I'm not saying everything, it can. So we can control the board functions by sending a set of instructions to the microcontroller on the board via Arduino IDE, referred as uploading software. This is Arduino IDE. I will come back to that. Unlike the most previous programmable circuit boards, Arduino does not need an extra piece of hardware. Yeah, in the wiring or some previous boards there was no USB port on the board, so it was difficult. There we need a separate programmer and connect it to the board, and the programmer connects to the PC. So it was a tough thing. I mean, that's not very easy. It may lead to some disconnection problem, but USB is better. So we will be using the Arduino Uno. The Arduino IDE uses a simplified version of C++. That's why it is easy for use to beginners, yet flexible enough for advanced users. Yeah, that's true. If you know C++, then Arduino will be a cheesecake for you. Arduino provides a standard form factor that breaks the function of microcontroller into more accessible package and also very inexpensive. Yeah, Arduino is very much inexpensive. You can search in the market also, they are really very inexpensive if you compare them with the other boards available in the market. Like some, you can consider some flight controller board, they are very much pricey, but you can build a flight controller using Arduino and it will be very much inexpensive. And standard form factor that breaks the function, yeah, you will if you have studied electronics in the in Calcutta University, there are electronics paper in the semester 4. Those who have opted, they will learn how microcontroller actually works and how to program them. But here it will be easy because we will be using the Arduino IDE to control the microcontroller. So let's move on. Now the basics, just the hardware thing. So this is the Arduino Uno board, and this long rectangular part is the microcontroller, which can be detached if you want. So you will see there are so many pins connected. These are all, someone are voltage pins, someone are input pins, output pins, like a general IC. There is a USB port, this is a power port, there are 5 volt 3.3 volt supply, 2 ground channels, one port for we can input voltage with this power port, this VIN channel or this USB port. There are some analog pins and these are digital pins. We will be discussing the hardware in details in the later session. This will be just brief introduction. So there is a microcontroller. We can load the program into the memory of the microcontroller. So it is called the brain of an Arduino because it is the main thing which controls the Arduino board and processes the input data to the output devices or actuators. There was a USB port which we can use to connect the Arduino board to computer, USB to serial chip. This was a part, but for the timing it is not so much important. So digital pins which can accept it can accept or generate 0 1 voltage like digital. There are analog pins. These are also tricky pins actually. These are not actual analog pins. They are little different. I will be discussing that later. There are 5 volt 3.3 volt power pins. These gives the power to external components which we connect to Arduino. We can power them externally through other power adapters also, but if we use low power mode then we can use these pins also. There are ground connection and there's a voltage in port which we can connect to the external power supply to power the Arduino board. Now there are so many accessories. There is an infinite list actually. These are some popular ones. The Arduino board, there's a breadboard, expansion shield, which we can connect this on this Arduino board to expand the connectivity. As I said it earlier, mini board, push buttons. These are sensors, vibrator switch. This is a potentiometer, IR remote. This is a photoresistor. This is DHT11 sensor which is used to get data about the temperature and humidity. We can measure that from the values generated from this. There's a flame sensor, buzzer. This is HCSR04. This is actually distance, ultrasonic distance sensor. This is a shift register. Different types of display, LEDs, RGB LED, servo motors. This is very useful thing. So you can search for the accessories. There are infinite possibilities. The limitation is you're just thinking. You can think as much, you can build that much. So now moving to the Arduino IDE. Actually, the IDE looks like this. This is the previous version. Actually, now Arduino IDE 2 version is also released, that is better, but this is also fine. You can install this one also, one or two. This consumes less memory, and the next one is consuming a little bit much. So the Arduino IDE is looks like this. There is the name of the board and the bootloader. It is shown here. The code is inserted here. The file name is here. This is the menu bar. This is some toolbar. This right symbol stands for the verify button or compile button. This arrow symbol stands for sending the code to the Arduino connected Arduino board. This is serial monitor button. These are also additional functionalities. We will be discussing that later. And this is the part where the uploading status is shown, like the program is loaded or there was an error, and error message shows here. So the program we write using the C++ language in the Arduino IDE is referred as sketch. This is very important thing. So everything here we write is known as sketch, and the anatomy of the sketch is very simple. There is a just void setup part and void loop part. This setup part runs only once and the loop part runs multiple times. I mean infinite times. If you don't insert any stop type command where to stop, then it will run for infinite. So setup is mainly used to initialize different input sensors, or you may perform some initial work which should be done only once. It will be it will be in the setup part, and the main code which runs multiple times, it should be put in this loop section. You can create additional functions also, and you can insert them here, that is allowed, but the main structure should be void setup and void loop. These two parts are mandatory for the sketch to perform. So the open source IDE makes it easy to write the code and upload it to the board. IDE contains a text editor for writing code, a message area, and a text console, a toolbar with buttons for common functions, and a series of menu. Okay. So the basic operation, like we consider, let's take an example, just like we will light up a LED if there is a fire. So basically I'm not showing the structure of the how to set up this. I'm just discussing what is the procedure actually. So if you can consider the Arduino board, we connect a flame sensor with the Arduino board, and there is a light also, LED also connected. So the first thing we need to do is read the sensor. So we have to do this multiple times, right? There is no single time operation in this scenario, because whenever there is a fire, we need to we have to turn on the LED. So we will read the sensor. If it is giving some positive value, I mean actually the sensor gives some voltage, and we need to compare with some reference voltage which gives the positive sign or the negative sign. We will be doing these programs in the later part in the course. So after reading the sensor value and processing the data, if it is found that there is a fire, we will turn on the light. We will wait for some few seconds, and then again, since this is in the loop part, so it will again go from the start. It will read the sensor again. If the fire is no more there, then light will not turn on, light will be turned off, and again we will be waiting for 2 seconds and again the loop starts, and this goes on. So we have not set any stop function here, but we can set stop function if we need. So I have explained these things. So the speed of a program is incredibly fast unless we instruct to slow down. It depends on the size of the program and time taken by the microcontroller to execute, but it is generally in microseconds. Yeah, here 2 seconds mean we have to add a delay of 2000 value. So now there is a platform called Tinkercut. I have mentioned that in the the code structure page. There is our Tinkercut platform where we can simulate these Arduino constructions. See, this is a just simple range finder structure. We write the code here. There is a serial monitor connected, which in this case we don't need a serial monitor because we have attached a display to it. We will be doing the programming here and we can simulate that here. We will be seeing this in this session also. We will not discuss the code, but we will see the simulation. So I instruct everybody to go to tinkercut.com and create your account so that you can also practice, and to do the projects you need to use the Tinkercut platform. So here comes the conclusion. Arduino is inexpensive, obviously. It runs on Windows, Mac OS, Linux, so it is very flexible. So why wait? Start tinkering. Now, since this was today's content and we will be seeing some simulations, so let me change the presentation. Okay, any doubt? First of all, any question?
না আপাতত না।
Okay, then moving to the next part. So let's open the code structure once. There we will be doing these projects also. There are two projects, this one and this one, which these can't be simulated on Tinkercad because there are no options. So if you can do it on yourself, like I will discuss everything, don't worry, but if you want to actually try it, because this is in your syllabus, you can, using your physics lab components from your physics lab, or if you have the components in your house also, you can try, because this needs a pendulum setup, this needs integration with Python also, where we can plot the data, and Tinkercad don't connect with Python, so there is no possibility. Others we will be doing here. Okay, so let's see the simulation first. This is the pin connections. This is the object distance detector. This is the ultrasonic distance sensor. So if we start the simulation, let me bring it to the center. You see the object is placed at 277.7 and it is showing 277 centimeter. If we change the value, it changes. I have not set up the decibel value there, so it is showing this much only. So I hope you are getting this. If we stop the simulation, you can see there is a code also. So we will be discussing it in the later section. Now let's start the first programming. How can we start programming without printing the hello world, right? So I just taken this Arduino Uno in my channel, in my this workspace, and I will add code to that. So we will not be connecting any external monitor, we will be just using the serial monitor. Serial monitor means it can serially transmit data to a monitor which is actually connected in our PC. So there is two sections. First, void setup, void loop. We will set up the serial connection by typing serial.begin. This starts the serial connection. So this is the initialization. It should be done only once, that's why I put it in the setup section. So serial.begin, and we need to mention the baud rate. Baud rate means at what speed the data transfer will occur. Now this speed should be such that the output device also is compatible with the Arduino, so we have to take care of that. Generally 9600 is most of the case is compatible with everyone. Some Bluetooth connection needs different speed also. So now we will be printing the thing in serial monitor, so we will be using serial dot print and write hello world. Sorry, we need to use this colons. You know, if you have experience with C++, and then add a delay of, let's say, 2 seconds, so it will be 2000 microseconds. So now switch on the serial monitor and start the simulation. So it is printing hello world. After 2 seconds again hello world, again after 2 seconds again hello world. So this is how we use the Tinkercut platform. We will be discussing in depth about the hardwares in the next session, and after that we will be going to the Arduino programming. So this will be the end of my presentation.
ডিলে আর বিগিন মানে সিরিয়াল ডট বিগিন আর ডিলে ওই জায়গাটা একবার বলো তো ওখানটা কেন করলো?
আমিও
মানে
বুঝলাম না
বিগিন 9600 এগুলো
Wait. Please repeat.
সিরিয়াল ডট বিগিন মানে বিগিনটা কেন দরকার হলো, আর ওই ওই অতটা অ্যামাউন্ট মানে 9600 এইটা কেন লিখলে, আর ওই ডিলেতে 2000 কেন লিখলে?
So if we need to, if you want to use the serial monitor, you need to initialize the monitor with the speed at which the data transfer should occur, right? So the command for that is serial.begin. Now this is the speed 9600 beats per second. This is also called baud rate. You will be this is also called the baud rate. You will be learning that after in the next session. So 9600 beats per second, the Arduino will transmit data to the serial monitor, and serial monitor will capture the data at 9600 beats per second and print it. Okay, so we need to use this to initialize. If we delete this part, the serial monitor will not get activated and nothing will print. Okay, so we initialize here with serial.begin and the speed, and in the loop section we enter serial.print to print something in the serial monitor we can also use println. If you use println, then this is the hello world and the next hello world will be in the next line. So this time we use println. Let me clear this. Hello world and delay of 2000. If we don't use delay, then it will print. I have said that Arduino is incredibly fast. It will continuously be printing hello world. Let's try what will happen. This is just making it slowing down the program. Let's start the simulation. Look, we can't even scroll with that speed. It is printing. So we need to add a delay so that this is hello world, so we don't have to care about that. But if it was some useful insight of data, then we need to follow the data, so we need a delay so that we can process the data from our side. So we add delay of 2 seconds. Now to add 2 seconds we need 2000 microseconds. Yeah, so 2000 microseconds delay is added. You can use 1000 also as per your wish. This is there is no restriction. So we start. Now it will print one after 1 second. Okay, any more question?
না, বুঝতে পেরেছি এবার।
So I will finish the lecture here. I will be discussing the hardware in the next session. Apurvo, if you have to say anything, you can.
আচ্ছা আমার একটা আচ্ছা আমি বলছি যে ওই যে সার্কিটটা পাশে দেখাচ্ছিল, হ্যালো,
Yeah,
যে সার্কিটটা কোডের পাশে সার্কিটটা দেখাচ্ছিল, সার্কিটটার সঙ্গে কোডটার কি সম্পর্ক?
let me go to the tab. We will be writing the code in the Arduino IDE. This is for simulation, that's why we are using Tinkercut. In reality we will be using the Arduino IDE to write the code and compile the code. And there was the arrow I showed you, you remember? The arrow actually pushes the code, which is valid code, pushes the code to the Arduino microcontroller. This was the microcontroller. So this code is now stored in the Arduino microcontroller, and when we start simulation, actually we are connecting the power to the Arduino board, and when it is powered, the program stored in the Arduino microcontroller starts performing by starting from the setup part. So the Arduino board begins the serial connection at 9600 baud rate. After that it goes to this section, the loop, which instructs it to print hello world with an enter at the end at a delay 1000 microseconds. So it is when this part completed, it again starts over from here. No, it will not go here anymore. So this is how it works. Now if you consider the previous part, there is also code. This code is inserted in the Arduino microcontroller, and if you just
মানে এটা দেখলে আমি বুঝতে পারবো, তাই তো, যে কিভাবে কোনটার সাথে কোন তার জয়েন করছে।
yeah, like the LCD connection is at 16 to this is lcd.begin. This code is this command is required to start the LCD connection, and this is required for serial connection. I have set up both in this case, so we can compare the data in the serial monitor and also in the LCD display. Now the loop part, which takes the data from this part. If you check, this sensor has a ground connection, a power terminal. This takes 5 + 5 volt, and this is the signal. So when it measures a distance, actually it sends a sound and receives it, and by calculating the time which the sound takes to return or reflect, we can calculate the distance. This is the basic principle of sonar. So we compute that thing by using this part, and the value is shown in the LCD display. So I guess your doubt is cleared. Anything more? So I'm done with this thing now. Apurva, are you there?
Hello. So I have nothing more to say. So what I say before, this is the demo class, and Ankush already taught you about the introductory part of Arduino. We will know in details on rest lectures. There are more than 6 to 7 projects and 6 to 7 lectures, also some mock tests. So we Team Mission Physics assure you you will be an expert in Arduino if you guys follow our instruction and maintain discipline. Okay, so what I say, this is the demo lecture and lecture one. Ankush also will share the lecture one note and other materials regarding lecture one in the demo classes link, demo classes WhatsApp group. Sorry, so don't worry. In order to continue the rest classes and full course, you have to register yourself in Mission Physics by buying a premium plan. So for registration, simply inbox me. I will let you know all the processes. Okay. Now rupees 400 for the full course because 20% off is ongoing, and those who are Calcutta University student, they will if they want to buy Arduino along with CUPLP4 or CU semester 4 Python, Calcutta University SEM for Python, they will avail the offer combo of that is 1650. This will also end on 10th April 11:59 p.m. Okay, thank you. Any query?